So right here in ShipStation, you're looking at a corrected, verified address. But just a couple minutes ago, this was still showing 1600 Pennsylvania Avenue, the White House. Instead of a team member manually spotting that error, our AI automation caught it, cross-referenced the customer's actual intent, and updated it instantly. There was no manual clicks involved and no shipping delays. That's intelligent automation. If you want to automatically update shipping addresses in ShipStation using AI without touching a single order manually, this is the exact workflow you need to see. Hey everyone, welcome back. I'm Adiraj, and today I'm walking you through building a fully automated AI agent that handles shipping address change requests from start to finish. Say a customer emails your support team asking to update their shipping address. Our AI reads the message, validates the order, parses the address, and then logs into ShipStation to update everything automatically. The entire process takes under 2 minutes with no human involvement. By the end of this video, you'll understand the architecture and know exactly how to build this yourself. And if you're in automations like this in e-commerce, hit subscribe. I build these every week and show you how to pull a human out of the loop. Now, before we dive into the build, let me quickly introduce the tech stack powering this automation. First off, as you can see, we have n8n right here. This is the automation platform connecting everything together. Next, we have Gorgias. Gorgias is your help desk. It manages all the customer support tickets and emails. When a customer sends a message, Gorgias is what fires that initial webhook. Then we have Shopify. Shopify stores all of your order data. We're going to query it via an API to validate that the order exists and belongs to the right customer before making any changes. Then we have ShipStation. ShipStation is where the shipping operations live. Think labels, addresses, carrier integrations, and this is what we're ultimately updating. And then we have Skyvern. It's an AI-powered browser automation tool that can navigate ShipStation visually, just like a human would, but it adapts when the UI changes, unlike traditional automation that breaks constantly. And then over here, back in our workflow, we use Gemini. Google's Gemini 2.0 Flash, which is the AI model doing the natural language understanding. It's going to read the customer's message, figure out if they actually want an address change, and extract the new address in a structured format that we can use. Each piece handles one part of the puzzle. Together, they create a fully autonomous system. And now let's see how they connect. Go ahead and create a free account on n8n and then click on create a new workflow, and then you'll land over here with it being totally blank. No worries, I've done all the work for you. Go to my school community and then locate this post with auto address update, and then just copy this JSON and then paste it over here. Then you'll have this exact flow. So let's start at the beginning. Every time a customer sends a message to Gorgias, your support platform fires a webhook to this n8n workflow, which is right over here. Think of this webhook like a doorbell. When someone rings it, Gorgias immediately sends all the data about that ticket to n8n. And so this webhook is listening on a specific URL path. When you set this up, you're going to copy this URL and then paste it into Gorgias under their HTTP integration settings. That tells them where to send the data. The method is set to post because we're receiving data, not requesting it, and the webhook returns a 200 OK response immediately, so Gorgias knows that we've received it. So how does the data look like when it first comes in? We get access to the ticket ID, the order number that the customer mentioned, their email, and the full text of their message. All of this gets passed to the next node automatically. This event-driven architecture means zero latency, and the workflow fires the instant a ticket is created. Next, we have the extract request data node. The raw data from the Gorgias is nested in a complex JSON structure, so this set node extracts just the fields that we need and then creates clean variables. We're using n8n's expression syntax to traverse the JSON payload. See these curly braces with the dollar signs? That's how we reference data from the previous nodes. We're pulling out the order number, the customer email, the ticket ID, and the original message text. Notice the order number extraction using a regex pattern to handle different formats. Whether a customer types hashtag 1001 or 1001, we normalize it to just the numeric value. This creates clean, reusable variables that we can reference throughout the rest of the workflow without having to dig through the nested objects every time. Next up, we have the get customer orders node. Over here, all we're doing is that we're validating that the order actually exists and belongs to the customer. We're using OAuth 2 authentication here, which is the secure way to connect to Shopify's API. This node makes a GET request to Shopify's REST API and pulls back all the orders associated with the customer's email address. Then we enter the find order node. Now here's where we need some custom logic. Shopify returns order names formatted like hashtag 1001, but customers might type it different ways in their email, so we need fuzzy matching. This JavaScript code loops through all the orders from Shopify and checks if the order name includes the number that the customer mentioned. We're using the includes method instead of strict equality because it's more forgiving. If we find a match, we return that order's full data object. If we don't find anything, we return an empty array which stops the workflow right here. And that's super critical. We never want to update an order that doesn't exist or was entered incorrectly. Next up, we have the parse address Gemini node. Now here comes the AI component, right? We're using Google's Gemini 2.0 Flash model for natural language processing. Flash is optimized for speed and cost, which makes it perfect for this use case. We need super fast intent detection and structured data extraction. Now here's the configuration, right? We send the customer's original message to Gemini and ask it to do two things. First, we need to determine if this is actually an address change request. And then second, if it is, we need to extract the new shipping address in a structured format. The AI also provides reasoning for its decision, and the key here is that we're prompting for a JSON response. This makes it super trivial to parse programmatically in the next step. Gemini analyzes the natural language, understands the context and intent, and then structures the output. Now, in terms of authentication, you're going to need an API key from Google AI Studio. It's free to start, and the Flash model costs fractions of a penny per request. So this scales efficiently even at a high volume. Next up, we enter our conditional routing logic. So this is an if node, and it is a decision point. We're checking if Gemini's response indicates that this is actually an address change request. In n8n, the if node evaluates conditions and routes data down different paths based on the result. So we're parsing Gemini's JSON response and checking the is address change field. If true, the data is going to flow down to the Skyvern automation path. If it's false, it's going to flow down to a different path that posts a node in Gorgias saying this isn't an address change and it's been left for human review. This branching logic is essential because it prevents the automation from running on the wrong type of ticket. We're being defensive here. We're only executing the expensive browser automation when we're confident it's the right thing to do. Then we have the update ShipStation Skyvern node. And here's where things get interesting. Skyvern is an AI-powered browser automation platform. Unlike traditional tools like Selenium or Puppeteer that rely on brittle CSS selectors or XPaths that break when websites change, Skyvern uses computer vision and large language models to understand web pages just like we would. We give Skyvern a natural language instruction set to achieve its goal of updating the shipping address, saving the changes, and then setting the order status to hold. We're using Skyvern 2.0 as the execution engine, and that's their latest model, which is significantly improved for accuracy and speed. Automation can typically take from 5 to 10 minutes. Now, Skyvern actually spins up a real Chrome browser instance in the cloud and executes all these steps visually. Then it's going to return a run ID, which we use to track our completion status. So now next up, we have the save run ID node. When Skyvern starts a task, it immediately returns run ID and executes asynchronously in the background. This is more efficient than synchronous blocking, but it means we need to pull the status to know when it's done. The set node saves that run ID as a variable. We also initialize an attempt counter at 0, and this tracks how many times we've actually checked the status. Next, we're going to go to the wait 15 seconds node. It looks like this is 30 seconds, so it should be called wait 30 seconds, but the idea over here is we're literally stopping the workflow for 30 seconds temporarily. We don't want to spam Skyvern's API with status checks every second. 30 seconds is a good balance between responsiveness and respecting the rate limits. After waiting, we make a GET request to Skyvern's task status endpoint using the run ID. We're reusing the same API credentials that we set up earlier. Skyvern is going to return a JSON object with a status field that can be running, completed, failed, or other states. We're specifically looking for completed over here. Next up, we have the increment counter node. This node increments the attempt count by 1. So the first loop it's 1, the second loop it's 2, and so on. We also carry forward a run ID because we need it for the next status check. And that is the isCompleted node. Over here we check if the status equals completed. If yes, we exit the loop and move on to the success logging. If no, we actually need to decide whether we need to keep waiting or timeout. And that brings us to the timeout node. This if node checks if we've exceeded the maximum number of attempts. We're allowing up to 100 attempts and about 30 seconds per attempt. That's about a 50-minute total timeout window. That's plenty of time even for slow browser automations. If we're still under 100 attempts, the data loops back to the wait node and we check again. This creates a polling loop. If we've exceeded 100 attempts, we break out and post a timeout message. Let's talk about this success note. When Skyvern completes successfully, we post an internal note back to the original Gorgias ticket. We're using Gorgias' messaging API with a post request. The channel parameter is set to internal note, which means only your support team can see this, not the customer. The node includes a success indicator, the order number, the new address, and confirmation that the order ID is on hold. Also, it's going to include the run ID. The run ID is critical for debugging. If something goes wrong, you can go into Skyvern's dashboard, paste that ID, and see the entire browser session replay with screenshots. For Gorgias authentication, you'll create an API key in their settings and use basic auth with your email and API key. For the Gorgias timeout node over here, if the automation times out after 50 minutes, we post a different internal note explaining the automation didn't complete and asking the team to check manually. It's also going to include the run ID for investigation. And then we have the not address change node right over here. If Gemini determines that this isn't an address change request at all, back at the conditional routing step, we post a note explaining the AI detected a different issue type and left it for human review. This prevents false positives from causing problems. Now, let's talk about why this architecture is effective. First off, we're using event-driven webhooks for real-time triggering. The moment a ticket is created, this workflow fires instantly. There's no polling Gorgias every minute checking for new tickets. And so second, we're validating data at multiple checkpoints. We verify that the order exists in Shopify, we use AI to confirm that it's actually an address change, we check in ShipStation that it hasn't shipped yet, and so each validation reduces the risk of errors. Third, we're using asynchronous execution with polling. The workflow doesn't block for 90 seconds waiting for the browser automation. Saves the run ID, does other processing, and checks back periodically. This is much more efficient. And fourth, we're creating a complete audit trail. Every action gets logged back to Gorgias with timestamps and unique identifiers. If a customer calls asking why their address changed, your support team can pull up the ticket and see exactly what happened and when. Let's go over the prior state of things before our automation kicks in. So over in Shopify, this is the order that we're messing with. It's order 1001. It's for selling plans, ski wax. It's got my information over here with the address set to the White House, and this is the email associated with it. Then in Gorgias, this is an empty inbox right now. So my ShipStation is connected to the Shopify account and the order number appeared over here. So I clicked into this. As you can see, this is the exact same information that was on the Shopify that you just saw. And this is the address which our agent is actually going to update. All right, so let's go over here. Now let's go to email. Let's craft out this email to send. For the two, you want to use the email address associated with your Gorgias help desk. That's going to be this for me. Student need help changing address. And for the actual body, we'll use this. There we go. All right, and you want to make sure that your n8n workflow is either set to active or you've clicked execute workflow over here, so we can actually see it visually execute. All right, so let's click send over here, and the ticket should quickly appear in Gorgias once it's sent, and then our workflow should start running. There we go, came up in Gorgias. And let's go to n8n, and our workflow is in action. So let's walk through this, right? The ticket came in, then we extracted all the data from the email and we parsed it out. So we cleaned it nicely so we can reference it as order number and all of these later throughout the nodes, right? Then we actually got the customer order that was associated with that order number in the email. We also, as you can see over here, we have the original message, customer email, and order number. And this is our output, right? So we got all of this in nice JSON, client details, confirmation number, contact email, all of the data that we need, right? Next up, we have the order matching logic. This actually just ran the JavaScript and matched the order number, it found it, and so order 1001 exists. This is the order object that got passed forward. Now this Gemini node over here, this is the AI basically just parsing and analyzing that message, and let's look at the response over here. So this Gemini returns structured JSON with the is address change marked as true and state. The new address was fully extracted with the street, city, state, and zip, with the reasoning explaining why it determined that this is an address change request. Then our if node lit up. This is that conditional node checking and evaluating if is address change is true. And that condition passed. So then the data took us to the Skyvern automation path, not this path right here. So we are right where we need to be. So let's go over to Skyvern and let's actually watch this browser automation play out. So you can see, so it's running right here. Let's click this. So right now Skyvern has already logged into the ShipStation using the details that we gave it in the prompt. How these cutting edge browser automation tools work is they break down the big task into mini goals, and then they reach the bigger goal like humans, conquering each of the smaller goals. So as you can see right over here, this is its reasoning and thought process. So right now it's actually going ahead and clicking on the order with order number 1001, which is that order that we told it to manipulate. It's checking that the user goal is to update the shipping address because the order has not been shipped yet. And it knows, using natural language, the edit button next to the ship to address will allow me to modify the address. So it's going to click that. It's very smart. And by the way, at this point in our n8n workflow, we're still polling and we're waiting for this to get done, right? We haven't moved on to the success or the timeout node. This is all still working in the background, right? Let's go back to Skyvern. Now it's actually entering that address that needs to be changed. And I'm not typing anything right now. This is the browser automation. This is our AI agent at work. So it's trying to get the city right now. There we go, got it. Los Angeles. Updating the state now. Oh, looks like it missed the state and the zip code. Let's see if it goes back and corrects itself. There we go. It actually saw that it needs to be corrected. Looks like it froze up here because it's continued. It says it's fixed it. So now it's trying to figure out how to put the order on hold. But I think the projection actually froze up on us. But it looks like it did update it all correctly, which is awesome. So now it's saying it needs to go to the hold section. And this is the tricky one actually, because there's no direct button available over here to put it on hold. So it actually has to go ahead and figure out which button, where is it, and how does it accomplish the goal successfully. And there we go. See the logic? This is the most relevant section to achieve the goal, putting the order on hold. It's reason that setting it to 21st is an appropriate choice, and now it's going to return a success because it has completed the entire workflow properly. Now we're going to go back over here, and in our n8n workflow, we should now hit the success note right here. There we go. We hit the success note. Now the moment of truth. Let's go back to Gorgias and refresh the ticket. And we should have an internal note here. There it is. It says automation complete, ShipStation address updated successfully with our run ID right here. So this note is internal. Only our support team can see it, but now anyone can see exactly what the automation did, when it happened, and they have the run ID for auditing. Now the real test, let's actually verify that the address actually changed in ShipStation. Let's go to ShipStation. And let's refresh the page right here. So now it's on hold. It's not awaiting shipment anymore. Now our address should be changed in here, and it is. There we go. That's your fully automated AI shipping address agent. Event-driven webhooks triggered in real time. AI parses the intent and extracts structured data from the natural language. Shopify is validating the orders, and Skyvern handles the browser automation with visual understanding that adapts to UI changes, all completely hands-free. If you want access to the workflow templates, detailed setup guides, and a community building similar automations, everything is inside my school community. The link is in the description. If this was valuable, hit that like button, subscribe for more automation workflows, and drop a comment telling me what workflow I should build next. Thanks for watching, and I'll see you in the next one.